Now we're going to talk about Erspan. We're going to include in this session what is Erspan, why do we need it. We're going to talk about the Erspan source device, the Erspan's destination device, and we are going to talk about features. Do we have filter VLAN with Erspan? Do we have filter ACL with Erspan? Do we have encapsulation replicate with Erspan? And we will see some configuration and troubleshooting commands. First of all, let's define what is Erspan. Erspan stands for Encapsulated Remote Switched Port Analyzer. In this case, we're going to use a layer 3 network in order to transport spanned information. What we will be able to accomplish with Erspan is monitoring traffic on a certain source at the source device, where this source device is going to encapsulate this copy of this traffic using an Erspan GRE tunnel, and then this source device is going to send this traffic to a destination device. Finally, this destination device is going to de-encapsulate this traffic and send it to a particular destination that can be one port or several ports. What we're saying here basically is that we're going to monitor traffic on a certain source device. This source device is going to make a copy of this traffic, and it is going to encapsulate this traffic using a GRE tunnel. It is going to also add an Erspan header. Now we are going to use a layer 3 network in order to transport this encapsulated traffic. We are going to send this copy of this traffic to a destination device that in turn is going to de-encapsulate it and send it to a capturing device. Now, why would we need Erspan? We are still going to use Erspan for telemetry, security, and troubleshooting purposes, but now the capturing device can be connected anywhere within the layer 3 network. Remember that we are going to use the layer 3 network as transport. So you have more freedom now. You can locate your telemetry server, your troubleshooting server, your security server anywhere within your layer 3 network. You are not bound now to connect these servers locally or within your layer 2 part of your network. As long as your source device and your destination device support IP and Erspan, you can now have more freedom in order to locate your servers anywhere. Now, in order to work, Erspan needs to perform encapsulation. Remember that we are going to do a copy of every single monitor Ethernet frame. So we are going to take these copies of these Ethernet frames and we are going to encapsulate them. We are going to add an IP header, a GRE header, and a Erspan header. Within the IP header, the protocol field will be set to 47 in order to indicate that a GRE header follows. Within the GRE header, the type field will be set to this number to indicate that an Erspan header follows. There are two types of Erspan headers, type 2 and type 3. Now, remember that in order to configure Erspan, we need to work with a source device and with the destination device. We are going to focus now on the source device. Within the source device, we are going to configure a monitor session with an ID. Remember that this number has a local scope. It does not travel over the network. Actually, you could use different numbers on your source device and destination device to identify this monitor session, although it is a good practice to use the same number. Within the source device, we are going to define what we are going to actually be monitoring, whether we are going to use ports or VLANs, and we can configure our filtering options. Remember that we can do filter VLANs or filter by ACL. Now, regarding the rules for the source device, these are pretty much the same rules as any other span feature out there. You can either monitor ports or VLANs, not both. If you go for ports, you can monitor several ports. If you go for VLANs, you can monitor several VLANs. We're still talking about how to configure source devices. This is an optional step. You can choose what Erspan header you are going to use for your encapsulation. By default, type 2 will be used, but you can choose to go for type 3. Type 3 supports timestamps, So we are going to be including a timestamp field that will be 32-bit wide for every single copy for your Ethernet frames that are being monitored. This will offer you a granularity of 100 nanoseconds. Now let's talk about the flow ID. This is actually a number that is going to get transport inside the Erspan header. This will help source and destination devices differentiate between different Erspan sessions. So this number must match on both ends, and remember that this is actually a number that travels through the network. So this must match at both source and destination. We're still talking about how to configure the source device. Remember that the source device is going to encapsulate traffic, so it needs to add an IP header. So we need to configure what will be the destination IP address that will be used as the destination IP for your IP header. This is an IP address that lives within your destination device. We need also provide an origin IP address. This is an IP address that lives within your source device. This will be used as a source IP for your IP header. These two pieces of information are mandatory, but you have optional attributes. You can set up the time to live and the DSCP values, and optionally also you can set up what will be the MTU for this encapsulation. Now let's talk about the destination device configuration. We are going to configure a monitor session ID that has local scope. Remember that it is a best practice to match the numbers for this session ID within your source device and destination device, even though these numbers have local scope. Then we are going to list what will be the destination ports. So we are going to define to which ports are connected our capturing devices. We must configure the Erspan flow ID. Remember that the Erspan flow ID travels through the Erspan header, so this number must match on both source device and destination device. And then we have to establish what will be the IP address. This is a tricky configuration. This is actually the IP address of your local device. This IP lives within your destination device. Even though when configuring we go into a source mode and then we establish an IP address, this is important. This IP address lives within your destination device. Remember that this IP address lives within your destination device, and this is the IP address that is used as a destination when you're configuring the source device. Now let's talk about some destination port rules. They may be layer 2 or layer 3 ports. Destination ports cannot be used to receive any traffic. They are dedicated for Erspan. Trunks can be used as destination ports, and one or many ports can be configured as destination. Now let's talk about what features do we have available for Erspan. We can select transmission traffic, reception traffic, or both, so this works with Erspan. We can use the option of filtering VLAN, so this works with Erspan. We can filter by ACL, so this works with Erspan. Remember that you can use an IPv4, IPv6, or MAC ACL. So how about the encapsulation replicate feature that we had with span and remote span? For Erspan, there is actually not an explicit encapsulation replicate option, but we can say that by default it is enabled because Erspan is going to monitor everything. It's going to include multicast traffic, VPDUs, so we can say that it is enabled by default even though it is not explicitly available when configuring Erspan. Now regarding the Erspan features for Catalyst 9000s, they can encapsulate up this amount of bytes. We can have up to 66 sessions supported with only 8 sources as maximum. We can use IPv4 and IPv6 for transport. Now, how to configure the source device? We need to issue the command monitor session. Remember that this number has a local scope. Then we need to set it up as an Erspan source. We are going to set up what will be the traffic that we are going to monitor, whether it is going to be ports or VLANs. And we need to establish whether we need to capture transmission traffic, reception traffic, or both. Both is the default. Then we can set up our filter. We can filter by ACL or by VLAN. Don't forget to issue no shutdown in order to enable this monitor session. Then we are going to enter into destination mode. Within the monitor session mode, we are going to provide the destination IP address, the source IP address, and the Erspan flow ID. Now this is how to configure the destination device. We are going to use the same command, monitor session. This number has a local scope, but then the type is going to be Erspan destination. We are going to set up what will be the ports or port where our capturing device will be connected to. This is where we are going to send the copy of the traffic. Remember to issue no shutdown. And then we are going to enter into source mode, where we are going to provide the Erspan flow ID, optionally a BRF. And remember that this IP address is an IP address that lives within your destination device. Now let's talk a little bit about troubleshooting. Remember that this feature makes use of your layer 3 network, so you have to make sure that your source device and your destination device have end-to-end reachability. You can use ping, trace route, or show IP routes. And then at your source device, you can issue this command, show monitor session Erspan source. And as your destination device, you can issue show monitor session Erspan destination. Now this is a summary of what we saw in this session. We talk about Erspan. Remember that the source and destination live in different devices. The transport between the source and destination is made over a layer 3 network. We can use filter VLAN, we can use filter ACLs. Regarding the encapsulation replicate option, there is actually not an encapsulation replicate option within Erspan, but we can say that it is enabled by default because it is going to capture everything. And we can make use of timestamps with Erspan if we enable the header type 3. That's it.